Yes, student, here we are with a new video. This is on chemical properties of phenol. Okay, student, this topic is very important for CBSE as well as for competitive exam. Okay, some question must ask on that content, therefore you have to pay proper attention. Okay, acidic strength of phenol. Student, you know that phenol, alcohol are acidic in nature. Okay, like here. And very first we are discussing water. This is the molecular formula of water. This is the molecular formula of alcohol, and this is the simple molecular formula of phenol, which is OH. What are the things common on all these three compounds? The common is what? Presence of OH group. This is the common thing. Getting? When in aqueous solution, it has polarity, that is the OH bond has polarity, that is electron pair can be shifted more towards oxygen atom. Therefore, when it dissociates, it forms RO anion plus it gives H cation. Being it gives H cation, therefore it is acidic. Similarly, here when it forms HO hydroxide ion plus form what? H cation, therefore it is also acidic in nature. And in the phenol, it converts into phenoxide ion. This is phenoxide ion minus charge plus it gives H cation, therefore it is also acidic. So all the three compounds are acidic in nature. It is because all these three are able to release H cation. But what are the differences, okay, between these three compounds? Student, actually what the differences is, even after releasing of H cation, whether the remaining species, that is this is the remaining species, this is the remaining species, and this is the remaining species, can they stabilize themselves or they cannot stabilize themselves? If they will stabilize themselves, then even after releasing of H cation, they will not attract it. That is, the H cation will present in ion, therefore will be the more acidic in nature. And if they are not able to stabilize itself, then it will again gain its H cation. That means the quantity of H cation in solution will decrease, therefore will be lesser acidic in nature. Student, in water, the hydroxide ion, that is the O attached is only with H. Okay, that is this H is very electron deficient, that is neither it is able to release electron nor able to gain electron. Therefore, that this H has no any effect. But remember here R, this is called electron precise alkyl radical, and student, you know that alkyl radical being electron precise has tendency to release electron. So if it will release electron on oxygen, oxygen is already electron efficient, isn't it? It is already electron efficient. Even if the R will release electron on oxygen, then the oxygen will more destabilize. That is here electron releasing group, which is what? R will destabilize what? Oxygen anion. Hence RO anion is unstable. Okay, now being it unstable, now it will show the tendency to gain hydrogen cation. So it will gain hydrogen cation, thus it is least acidic. While in case of water, H, neither it can stabilize nor it can destabilize, therefore what we can say, it is moderate acidic. That is, it is more acidic as compared to what? Alcohol. But in case of phenol, now there is a phenoxide ion, and student, phenoxide ion is attached with a benzene ring, and the benzene ring has tendency that it withdraws electron from oxygen atom. That is here phenyl being unstable withdraws electron from oxygen anion. Hence stabilizes oxygen anion. Now, if the oxygen anion will stabilize, then it will not show the tendency to gain hydrogen cation. So, it does not attracts what hydrogen cation which it earlier lost. Hence, is most acidic. So, student, now can you write the answer? Why do phenol is most acidic between alcohols, water and phenol? This is due to the stabilization of oxygen anion. Again, student, we can understand it on the basis of that after losing hydrogen cation, whether the remaining species is stable or unstable. If it is highly unstable, then it will gain hydrogen cation, and if it is less unstable, then it will difficultly gain hydrogen cation. So, as more quantity of hydrogen cation will be given by a compound is known as more acidic in nature. Now, student, we will discuss comparison of acidic strength of phenol with its derivatives. Student, derivatives means what? Derivatives means what? If in benzene ring there are electron releasing group or electron withdrawing group are present, then it is called derivatives. Like if we consider simply a simple phenol, this is OH. This is a simple phenol. But what is the meaning of its derivative? Derivative means if with phenol, like here, this is a phenol, there is a electron withdrawing group. Okay. Now, what are the electron withdrawing group? These electron withdrawing group may be NO2, that may be COOH. These are called electron withdrawing group. And other type of derivatives, these are what? Like here, phenol, and the derivative, if we are making electron releasing group, this electron releasing group is like what? CH3. Then it will be called Rishol. If we are using CH3, then it will become what? Rishol. So, student, if electron withdrawing group is there, then what will be the acidic strength of phenol? Phenol is also already acidic in nature if electron withdrawing group is attached to it. Electron withdrawing group means what? Which withdraws electron from the attached group. So, if it will withdraw electron, then here the phenoxide ion, this is O anion, phenoxide ion, okay, which is what? Unstable. Why unstable? Due to efficiency of electron. If electron withdrawing group is there, then it will withdraw electron from oxygen, and therefore the oxygen will become more stable, and if it will become more stable, then it will not tend to gain electron. That means what? In that case, the compound will become even more acidic as compared to phenol. Are you getting me? I am explaining again. The phenoxide ion is unstable, okay, due to efficiency of electron. If there are electron withdrawing group, so this electron withdrawing group will withdraw electron from here, benzene ring, and if it will withdraw electron from benzene ring, then the oxygen will become electron deficient. Electron deficient, that is, now it will become more stable, and if it will become more stable, then it will become more acidic as compared to phenol. While student, in case of electron releasing group will release electron on benzene ring, therefore the electron will be gained by oxygen, therefore the phenoxide ion formed by it, this is what? Phenoxide ion formed by it will become even more electron efficient. Getting? And if it will become more electron efficient, then it will not tend to gain electron. That means what? it will become what? Less acidic as compared to this one. Thus we can say here the electron releasing group will decreases the acidic nature, while the electron withdrawing group increases the acidic nature. Is that clear? Now student, there is one more thing here. The electron withdrawing group, okay, like here electron withdrawing group, it will be of 3 types. Like here, the position of electron withdrawing group, this is what O anion. Suppose it is in CH3 group. Okay, sorry, we are taking what? Example of NO2. One more thing, if we are taking the example of meta position, that is here will be NO2, and if we are taking one more example where the electron withdrawing group is present in para position, that is here is the that one. So students, you know that due to ortho effect, this is called most acidic. So that one is most acidic, and you know that the phenol in OH group is ortho para directing. Therefore, after that, little less acidic is para compound, and the least acidic will be what? Nitro compound. But all these 3 are more acidic as compared to phenol. Are you getting? Similarly, student, here, okay, in case of we are taking CH3 here, 1. In case of we are taking one more OH and CH3, and in case of we are taking one more substituent OH, where it is in para position, and that is para position. Then which one will be the most acidic among all these things? So student, the meta position will be most acidic, that is first one. Okay, after that para position, and then what? Ortho position. But all these are less acidic as compared to phenol. So these 3 are less acidic than phenol. Yes.